what you'll notice is that it doesn't actually print all of those things that we saw, except for done. Now, why is that? Right. So remember, we talked about hot versus cold observables. Well, this one is a cold observable. No one says, I'm interested in what you have to do right now. So it just doesn't print anything. Now, just to prove I'm not lying, this time I've added in a subscriber. And if we run the test again, we're going to get, the full output that we expected. There we go. Good. So, time for a quiz. Observables can A, emit items, B, be cold, C, be hot, or D, all of the above. Yes, D. I want you to feel smart, okay? I'm doing this for you, all right? Okay, great, yes. Observables can do all of these things, and that's why it's a key aspect of programming with rxjava. So this time, we're going to move on to talk about the observer. And the observer is the abstraction that rxjava uses for listening to, or as the name implies, observing the various items or events that the observable is producing. So in its most complex form, it's this type of interface here. And I'm going to go through it. Sorry, there's more people over here. I'll be back. Okay. So the observer takes in a type T. And this is how it's saying, this is the particular item that I'm going to be responsible for. Next, it has this method onError. So it's one thing you'll hear people say often about rxjava. rxjava treats errors like a first-class citizen. So this is how it does it. It has this method. It receives a throwable if anything goes wrong. Next, we have onComplete. We talked about this a little bit before. This is how we say we're done. There's nothing else. onNext takes a T of type T. This is the thing I'm actually interested in. So if I want to observe users, this is where I get a user. If I want to observe smiley faces, this is where I'd get a smiley face. And finally, onSubscribe, which receives a disposable. So this is how we can say, like, I'm busy. I can't keep listening to all your events, however you want to think about it. So an observer also has a life cycle, and the order of those methods need to be respected. So whenever it is subscribed, it has to have a call to the onSubscribe method. And then during the normal flow of its life cycle, there can be 0, 1, or many calls to its onNext method. And then finally, it can have a call to onComplete if it's successful, or it can have a call to onError in the case of some particular type of failure. So here's an example implementation of that interface, and we're just overriding all the methods and logging whatever we get back. So if we connect it to our observable and then we run it, notice what happens. Okay, so you see all of that information. It goes through and it calls all of the methods, and we get the various results that we were hoping for. But sometimes observers just don't really care about all those other things. And for this reason, there's an interface called consumer that rxjava has made available. And it has one method, accept, which you can more or less think of as the onNext call of the whole observer interface. And so here's an implementation of it where we just override its method, and I even left the signature of the print line to onNext, so we can see that they're basically synonymous. So if we run this code connected to our observable, then we're going to get the output that we're interested in, which is pretty cool. But if you look closely, you'll see that the IDE is giving us this gray squiggly line. So it's letting us know, hey, something's up with this syntax here. And essentially, we can convert this to a lambda. So if we go and we convert our consumer to a lambda, we end up with something like this. But we're not using this variable anywhere else, so we can go ahead and just jam it into the subscribe method. But once you see some Kotlin code like this, you're going to get another error because it's like, hey, I already know, I really don't need you to add this extra constructor. So you can just take it out. You're getting closer. But now you have a lambda as the last parameter in a method. Kotlin says, get rid of those parentheses. Okay, we're getting closer. This time, we can go ahead and drop that declaration of the lambda in the arrow because Kotlin knows, hey, there's just this one parameter in the lambda. I already know its type. It's not necessary, so I'm just going to use it. And this is what you'll see most often when you're looking at rxjava code in Kotlin. So if we plop it in, run it, we're going to get the same exact result before. Okay? Now, pop quiz. Observers have a life cycle, always complete, never error, or all of the above. What would you say? Right, it's A. Not that nice. Wasn't going to all be D. Right? They have a life cycle. So they go through that little process that we saw before in the diagram, and they can either complete successfully or end in or an error. So now we're ready to talk about the operators. And the operators are what help you to transform, combine, and as we saw earlier, create observables. So let's look at an example. And we're going to take our friend, the map operator that we've seen a few times already, integer that it receives. So just to put it like even more clearly, these two things are the same. So one, obviously extremely more concise than the other. And anytime you're working with rxjava and Kotlin or Java 8, etc., it's really helpful to break it out sometimes into the expanded version so you can better wrap your head around what the particular operator is doing. Okay, so what's the output of this particular code? We're taking an observable of just the numbers 1, 2, and 3. We're using the map operator to double it, and then we're going to print it out. Here are your options: A, B, C, or D. Right, it's C, okay? So 1 doubled is 2, 2 doubled is 4, and 3 doubled is 6. My math skills are amazing, right? You're impressed, okay? So we got it together, right? We're starting to really wrap our heads around rxjava. Let's look at one more. We're going to take that same code, but this time we're going to add the filter, and we're going to reject things that are not less than 6. Okay, is it A, B, C, or D? Right? It's going to be B because the last number, 6, right, is obviously not less than 6. So hopefully you're starting to feel really comfortable with this like very basic rxjava. But now here's an operator that you're going to come across a lot when you start working with rxjava, and that's flat map. And this is its marble diagram. And it gives us some insight into how flat map works. At first glance, it may seem very similar to the map operator, but it differs in a few key ways. So first, flat map's job is to transform an item into an observable of potentially a different item. Okay, so that's what its transform function does. So let's look at this in action. So here's our rxjava code. We're all about positivity. So whenever we're getting a frown, we're going to just flat map that to an observable of some down arrows. Okay? So if we start out with our two observables, the source and what's going to be our result, once that subscription is triggered, it's going to get busy emitting new items, and we're going to get the first frown. Flat map is going to jump in, create an observable of the down arrow, subscribe to it, and then emit it in a single. And the same thing is going to happen the next time we get another frown. Create an observable and emit it. What's interesting is the subscriber has no idea that all of this is going on. All they know is I have two down arrows that I need to pay attention to. And so why would this be really cool and super important? Well, because now when you're using FlatMap, you can do long-running asynchronous operations without blocking the main thread. So let's look at an example. Say you have an observable of users, but you're actually interested in all of the blog posts that they write. You can now use FlatMap to say, hey, for every single user, go off, give me all of their blog posts, and then I'll subscribe to it and just print them out. And you can think of many other applications of working with FlatMap in order to do these type of things. So FlatMap is super powerful, and there are many other operators just like it whenever you're working with rxjava. So someone's going to say, hey, annyce, what about flowables and maybes and singles and disposables and all these other things? Literally, the list can go on and on and on. Remember, this is rxjava in baby steps. And I want to save something for V2 of this talk. So, should you use rxjava, right? That's the big question. Well, think about these things. Do you like functional programming? Do you need to process items asynchronously? Do you